Hey guys, it's Mr. Morrow again with another edition of Morrow Teaches Online. Again, at this point, I think my followers are in the millions now. Again, it's been such a great road, but unfortunately, this road is coming to an end real soon because we only have two more lessons left of the algebra curriculum. Again, shout out to all my followers. Again, couldn't have done it without you. So here we go. It's day two of scatter plots, which is how do we find the line of best fit? So let's do this. So let's look at our homework. Now, your graphs on your homework might look differently based on what you used as a scale. Now, technically, there's something wrong with this graph. I hate seeing that right there. You cannot start at 15. Remember what I talked about in the last video? If you drew a break line first, yeah, you could have made that 15. So this graph is actually like technically wrong, but it should look something like that. And then what kind of a correlation is this? It's a negative correlation. Now, did it ever actually say draw the line of best fit? Yeah, so you did not need to draw that line. That's actually today's topic with the line, but we never actually answered the question. So it says, is this positive, negative, or no correlation? So this is a negative correlation. And just ask yourself, doesn't that make sense? I don't know about you, but when do you like to drink hot chocolate? Personally, I actually hate hot chocolate. I know I'm a weirdo. But when do you like to drink hot chocolate? In the summertime or in the wintertime? And I bet a lot of you just said the wintertime. So usually the hotter it gets, the less hot chocolate is being drank. So the colder it is, the more hot chocolate. So again, as temperature goes up, hot chocolate sales go down. So that's a negative correlation. The next one, that should be a positive correlation. Now, again, if you're like, my graph looks different, well, that depends on what you used as a scale. If you went by tens, it would look a lot different. So all we're looking for is, did your graph show a positive trend? So it should have been going up like that. So, and doesn't that make sense? Usually the hotter it gets, the more liquids that are being drank because usually you're dehydrated. So again, the hotter it is, the more juice is being sold. So that's a positive relationship. Now, this one, some of you might have tried to say positive. In my mind, there's not much going on. There looks pretty level. There doesn't look to be a trend. So this is a no correlation. And that makes sense. How many of you like eating sandwiches in the wintertime? How many of you like eating sandwiches in the summertime? Temperature doesn't usually affect your need to eat sandwiches. I don't think, wow, it's hot now. Now I need a sandwich. Or it's cold now. I need a sandwich now. So you did not need to do that. And again, it may look different based on the scale you used. Okay, so today's lesson gets a little bit more in depth on what a best fit line is. I know I brought it up in the last video, but now we go a little bit more in depth of just positive and negative. Now there could be strong positive or weak positive correlations. So here we go. So first of all, it says when data shows a positive or negative correlation, you can model the trend in the data using a line of fit. It could also be called a line of best fit. I've heard a best fit line, and I've also heard linear regression, which you're going to hear later on in this lesson. So there's usually like 4 different ways they can say the same thing. Again, if you hear line and best or linear regression, all of them have to do with drawing a line, okay? So it says draw a line of fit. Now, what you want to do is, obviously, you're not going to, again, what I said in the last video, you're not going to play connect the dots, like connect the dots, la, 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 connect the, again, you're not going to do that. You're drawing a line. But obviously, there's no way to draw one line through all the dots. So what you want to do is draw a line through the majority of the dots, or at least through the middle. Now, you want to have about the same amount of dots above the line as you do below the line. Now, that doesn't mean doing this. Whoops. Let me make that a little bit more accurate. You don't want to do that where you're like, same amount of dots above and below. Yeah, but that doesn't show the trend. That's why it's called a trend line also. Because again, you want to show the trend. So what you want to do is, and sometimes I mess it up on the first one. Let's try this. So you want to try to get a line through about the middle of them. Okay? And then you would draw an arrow only on one side because you can't have negative hours worked. You can't have negative dollars. So here's what you should notice again. Do you see how there's like one dot that's definitely not touching the line and there's about one dot below that's not touching the line? You know, maybe there's 2 dots below and 1 dot below. That's fine. This would be a good best fit line. What you would not want is something like this. Oops, I moved the wrong thing. Yeah, good enough. I'll move that. Do you see how that's not a good best fit line? Where do you see all the dots? All the dots are above it. So that's no good. Just like if I drew the line like, hello, come back here. Just like if I drew even drawing that is not good. Because look where all the dots are. The dots are below. So you want to get about the same amount of dots above the line and below it. That's about good. Maybe a little. You know, you don't need to go crazy over it. Like, we usually give you a little bit of wiggle room on what will count. I mean, this is pretty good. Oops. No, stop moving. Come on. Oh my. All right, so that's pretty good. So doesn't that make sense that the more hours you work, the more money you'll probably make? So we say that this is a strong positive correlation. And what we mean by a strong correlation, meaning there is definitely a relationship between the hours you work and the amount of money you get paid. The more hours you work, shouldn't you get paid more for that? And here's how you know it was a strong positive correlation. Look where all the dots are. Do you see all the dots are really, really, really close to that line? That's a strong positive correlation, okay? But if you look at the next one, which I'll draw, so we're going to draw our best fit line. But in this case, I'm not going to be hitting that many dots, but I want to get it through like the middle of them. So that's pretty good. And again, what you should notice is there about the same amount of dots above and below? So there's, 5 dots above and about 5 dots below. So that's a very good graph. So that would be a good best fit line. But look at this one. Where do you see the dots now? The dots are much further away from that line. So we would call that a weak negative correlation. And that means, the age in years. So like Honda cars, the older your car is, probably the less you can sell it for. But why is that not a strong correlation? Well, haven't you guys ever heard of like a vintage car? If your car is vintage, usually you can sell that for a lot. So even though there's definitely a relationship between the older a car, the less you can sell it for, it doesn't mean that if it's old, you can't sell it for a lot. It might not really be a nice car in good shape. Like maybe you've never driven it. So that's a weaker correlation, meaning there is a relationship, but not as strong. Okay? So this part gets a little complicated. It's called residuals. So a residual is the difference of the y value of a data point and the corresponding y value found using the line. A residual can be positive, negative, or 0. So here's what I mean. Here's your best fit line that I just showed you how to draw. Do you remember looking and seeing that some dots were above it, some dots were below it? So here's what we say. The residual is how far away is that dot from that line? Just like here, how far away is that dot from that line? If the dot you plotted is above the line, we say it's a positive residual. If the dot you plotted is below the line, we say that's a negative residual because it's below it. And if the dot is on the line, do you see how there could be a dot on the line? If there's a dot on the line, we would say that's 0 residual. Okay? So a scatter plot of residuals. So if you were to plot these, a scatter plot of the residuals show how well a model fits a data set. If the model is a good fit, then the absolute values of the residuals are relatively small points. Will be more or less evenly dispersed about the horizontal axis. So I know you're reading all this and you're like, what? Is this a different language? I know, it's a little confusing. I'll sum it up to make it easier for you guys. If the model is not a good fit, then the residual points will form some type of pattern that suggests that the data is not linear. So wildly scattered residual points suggest that the data might have no correlation. So here's what you have to look for. Do you see how these dots are all over the place? And they plotted the residuals. So what I mean by they plotted the residuals, let's see what this residual was. How far away was this dot away from this point? 1, 2, 3. So we would say the residual was +3 because it was 3 away from the best fit line. For this, the negative one, how far away was this? 1, 2, but since we're below the line, we say it's -2. So if I were to now plot these, like, okay, one was plus, so in this case, this was at +2, this was at -2, this was at -2, this was at -2, this was a 0 residual, 0 residual, 2 residual, 2 residual. There is no pattern there. They look random. So here's what you need to memorize, okay? If there's no pattern, which this is, we say it's a good fit model. Oops, good fit or a good model, okay? But we say usually good fit. But sometimes when you graph the points, there's a distinct pattern. Look at when I plot these residuals. So what does that kind of look like? Some of you are like absolute value. Usually we don't talk absolute value. Remember parabolas? So the way you pronounce this word is parabolic. You're definitely going to learn more about that in Algebra 2. But you would never actually draw this. But do you see what I mean by it kind of looks like a quadratic? In this case, there was a pattern. So if there is a pattern, it's not a good fit to draw a best fit line. Not a good fit. Because then you wouldn't draw a best fit line. You would probably draw a best fit, like quadratic, like parabolic shape. So again, I know this was confusing and they barely ever ask it. All you need to know is if there's no pattern, it's a good fit to draw a best fit line. If there is a pattern, don't draw a best fit line. So let's see if we understand these questions now. It says, which of the following residual plots indicate a linear model? Now, which one looks so tempting to pick? Most kids will pick number 1 because they're like, oh my God, it's a line. But what did I just say? We're talking about a residual plot. Are we looking for a pattern? No. So if we're looking for the most appropriate, we're looking for one that has no pattern. So which one of these has no pattern? And I'm hoping you're all saying it's number 2, and it's correct. And the Regents does love asking these kind of questions. They have definitely been asking it a lot more in recent years. But again, if there's no pattern, we consider that a good fit. So then for the next question, which of the following residual plots would indicate that a linear model would be an inappropriate choice? So if you look at number 1, it's random. There is no pattern. That's a good choice. This one's random. That's a good choice. This one's random. That's a good choice. Wait a second. Number 4. Do you see how there was a pattern? That would be an inappropriate one. So again, the part that us math teachers see the most mistakes in is clearly for this question, going back to number 1, most kids would pick number 1 because they hear the word line and they pick the one that's a line. But if you ever hear the word residual, okay, don't pick the one that looks like a line. Pick the one that's no pattern. Okay? So now for this question, it says a set of data is a fit with a linear regression. So you're going to hear this word a ton now. Linear regression. Again, that's just the best fit line or the line of best fit. It's just the fancier name for it. Just like instead of calling a quadratic a U, we call it a parabola. It's just the fancier name. So linear regression. So here we go. For the best fit line, so we have some random scatter plot, and they're saying this equation, they graphed it. So here's the graph. Ta-da! If the observed value when x was 10 and y was 62. So y was 62. Again, I'm just making stuff up, and I already know what the graph should look like, so here's how I know how to do it. So if you're like, how did you know it was going to go there? That I do this. So 62 would be like right there if you were to graph it. Come here. Now, where do you see the dot? Is the dot above the line or below the line? Below. So it's going to be a negative residual, okay? So here we go. So here's how I'm doing all this in my head. Do you see how x is 10? Plug in 10 then for your equation. So 5.2, I'm using that equation they gave me, 5.2, but plug in 10 plus 18. When you do 5.2 times 10 plus 18, you get 70. So this isn't the actual point. This is just what we're predicting it to be, which is this line. So when you predict it, we predicted it was going to be at 70. But when you actually plotted it, it was actually at 62. So where do you see the dot? It's below. So if it's below, it will be a negative residual. Okay? So what's 62 minus 70? Negative 8. And there's your answer. Because we had to go down 8 from the predicted line to get to the actual point. Okay? Again, I know these questions get a little confusing. The part you really need to know is coming up. So Graphing calculators use a method called linear regression, which is what I've been talking about, to find a precise line called a line of best fit. So again, I've been mentioning this. Sometimes you hear it as a line of best fit, a best fit line, a linear regression, a trend line. All of those mean the same thing. This line best models a set of data. A calculator often gives you an R. And the way to remember, I know you would think, and it's called the correlation coefficient, and you would think, oh my God, it's going to be a C for correlation. No, just think of correlation. Correlation. So on the calculator, and I'll show you how to do it, when you see the R, that's called the correlation coefficient. Now that number can only be between -1 and 1. So if you're like, oh, Mr. Morrow, I got a correlation coefficient of 3, it's wrong. The only thing you can get is something between -1 and 1 and anything in between. So it's like a spectrum, as you can see. Do you see the spectrum right here? Whoop. Yeah. So it's just a spectrum that can go from 1 to -1. Now here's what this means. The calculator will tell you if it's a positive correlation, if it's a negative correlation, or if there's no correlation. Not only that, but it will tell you if it's a strong correlation, a moderate one, or a weak correlation. So the calculator will tell you everything. So if you remember in the beginning of this packet, this chapter, I said the calculator was going to do most of the work. Well, the calculator will do most of the work. So like, for example, if you were to type in all the data, which I'll show you in a second, and you get that the R came out to 0.98. Here's what that means. First of all, is 0.98 a positive number or a negative? Positive, because there's no negative symbol. Okay, and is 0.98 close to 1 or close to 0? So again, it has nothing to do with money, but money seems to help us in life. If I have 98 cents, is that closer to $1 or closer to $0? And you should all say that's really, really close to $1. So then we would say it's strong. So here's what you need to know. The further you get to the outsides, the further you get to 1 or -1, the stronger the correlation is. The closer you get to 0, though, the closer you get to 0, the weaker the correlation gets. Okay? So again, we just said 0.98 would be a very strong positive correlation. If I gave you 0.23, that is not close to 1. We would call that a weak positive correlation. Okay? And just like if I said, well, what about -0.96? Isn't that really, really, really close to -1? So then that would be a strong negative correlation. So again, the closer you get to the outsides, the closer you get to 1 or -1, the stronger the correlation is. Okay? So here's a little thing to help you out. And again, money seems to always help me. If it's bigger than 0.75, so like 0.76, 0.80, 0.95, even -0.95, if it's a number bigger than like 0.75, so if it's bigger than 3/4, it's a strong correlation. Okay? If it's between half, which is 0.50, if it's between half or 3/4, so if it's between 50 cents and 75 cents, and again, this has nothing to do with money, but money seems to help us, we call it a moderate correlation. So if I said the correlation coefficient was 0.62, that's between 0.50, I feel like adding a 0 would help, between 0.50 and 0.75, then you would say it's a moderate correlation. And if it's anything less than half, that would be a weak correlation. And if it's so small, if it's like 0.02, you might say it's no correlation at all. Now, some kids go, well, how do they come up with this number? How does the calculator do? You have to use this equation. Do you really want to use that equation? I didn't think so. So you never have to use it. So now I'm going to show you how to do this. So we're not going to do the celebrity scatter plot like I said. So here we go. Go to this question. Now, everybody go to your calculators, because if you don't turn this on, your calculators will never show you the correlation coefficient. So first thing, everybody turn on your calculators. You're going to go to mode right next to the blue button. You see how it says mode? If you click mode, you get this screen. Now I need you to scroll up, because again, if you don't do this, you're not going to see it. If you read all this stuff, do you see how it says stat diagnostics? Do you see how where it's blinking right now? It says stat diagnostics. We need that on. So if you go to the right, Do you see how it's blinking on? Click enter. Do you see how now I turn stat diagnostics on? Now press second mode, which is quit, and now everything should work. So where do we go for all our statistic needs? Go to stat, go to edit, and if you have any numbers there, remember, you go up, press clear, go back down. Okay, so now let's see what we need to graph. So do you see how there's two columns? So this you're going to type into L1, this you're going to type into L2. So what it wants us to find is the line of best fit and then interpret the correlation coefficient. And again, I'll show you how the calculator will do almost all of that for us. So let's type this in our calculator. So go to stat edit, and now you're going to type in, let me get it ready. Okay, so we're going to type in the first column, 140. And again, the calculator can only type it in is if you do it right. 130, 130, 125, and 110, and make sure you press enter so it's locked in. So we got the first column. Now type in the second column. 130, 125, 140, 125, and 115. Okay? Now, here's the rule. Let's say you forgot a number. Let's say you forgot the 130 and you're like, oh, I'll just put it at the bottom. The rule is if you're going to put 130 at the bottom, you better put the number that goes with 130. You see how it's 140? You better put that at the bottom too. Those numbers have to be next to each other. Okay? So now you're going to press stat. We're done editing. Go over to calc. Now, the only thing we've shown you so far is number 1. If you look at number 4, you see how it says linreg? Linear regression. So that's the other button you need to know. It's number 4. So if you click 4, again, you're just going to click enter, enter, enter. Some of you may have the screen, some of you may not. And again, if you didn't see on settings, turn the diagnostics on, I'll show you another way if you write in Google Classroom how else to turn it on. Now, you see a lot of numbers here and you probably don't understand what any of you are looking at. So you see how it says y equals ax plus b? Doesn't that kind of look like an equation from early on in the year? Doesn't it kind of look like y equals mx plus b? The only difference is they put an a instead of an m. But what they're doing is they're giving you the equation to write. So it says find the line of best fit. So all you got to do is copy this. So write y equals, so again, I'm going to have to do this in installments. So write y equals, and now you go back to your calculator. Now we're going to round this to the nearest hundredth, meaning 2 decimal places. So 0.583. Does that 3 tell me to round up or keep it the same? Keep it the same. So it tells me to write the a now. Do you see how it tells me to write the a? So let's write the a, 0.58. And then it says after the a, write an x. So let's do that. 0.58, and then write an x. And now the rest of it, let's go to the calculator. Now it says plus b. Well, what's my b? 52.91. And what does that 6 tell me to do? Round it up to a 2. So then all you're going to do is write plus 52.92. And there's your answer. The calculator did all the work for you. It says find the line of best fit. We just did. Now the second question says interpret the correlation coefficient. Now, here's how you know you pressed the buttons right. If you didn't turn those diagnostics on, the stat diagnostics on, you would not be seeing the R's right now. So if you didn't get the R's, you need to rewind the video and learn again how to turn the diagnostics on. Now, do you notice how it says R squared and R? We never use the R squared, we just use the R. So let's write the R and again round it to 2 decimal places. So you see how the R says 0.70? So let's write that. We're going to write, and I'm going to have to put it down here, R is 0.70. But it didn't say find the correlation coefficient. It said interpret it. So here's how you interpret it. First of all, is 0.70 a positive number or a negative number? It's positive. So you're going to write positive correlation. Okay. But now we need to get more specific. You can't just write positive. What about it? So that's when you need to go back to this page. So where would you find 0.70? Do you agree that 0.70 would be between 0.50 and 0.75? So then you're going to write the word moderate. So it's not just a positive correlation, it's a moderate one. Meaning there's a relationship, but not a strong one, just there is a relationship. So let's see what this means. let's look at the question one more time. It's comparing your IQ score, so your intelligence versus your creativity. And what we just found out was that there was a moderate positive correlation. And that's very, very true, okay? Meaning, usually the smarter you are, the more creative you are, and the more you're able to think outside of the box. And that makes total sense. Now, this is something that doctors use a lot in real life. When they're running tests to see if a new drug is working, they'll run tests and they'll see what kind of correlation there was. What we're hoping for is a very strong positive correlation, meaning the more, the more people that took the drug, the more people that were healthier. All right, that's what they're looking for, is for those strong results. If they found out the correlation came out to 0.23, that means there was not a very good effect on that drug helping out with that illness. So this is something we use a lot in real life, okay? So we got, I think, one more question. So let's do it. So this one's kind of a pain in the butt because there's a lot of numbers to type. But again, the first line is you're going to type into L1. The second line, you're going to type into L2. So we're going to go to our calculator. We're going to go to Stat, Edit, and remember to clear it, you go up to L2, press clear, go back down, go over, go up to L1, press clear, go back down. Now, to save time, I'm going to pause the video, and then I'm going to type in all the numbers so that we can get this moving a little faster. So right now, you should be typing in all those numbers and see if you get the same numbers. So here we go. Okay, so magically, all the numbers appeared because I paused the video. Again, the only times you may screw up is because you typed in a number wrong. But again, if you missed one of the numbers, you better make sure that the number that goes with it in L2 is also written next to that number. They have to be next to each other. So now we're done typing in all the numbers. And again, sometimes you get error messages because you didn't type the same amount of numbers, meaning you forgot a number. If there's 10 in one column, there better be 10 in the other column. So now you press Stat. You go over to Calc, okay? And again, we're going to click 4 because we want to find a best fit line, otherwise known as a linear regression. So you're going to click 4. Some of you may get this screen, some of you might not. You're going to click Enter until you see this appear. And again, if you're not getting that, the R's, that's because you didn't turn the diagnostics on. You have to. And again, rewatch the video. So again, you're going to use the A, you're going to use the B, you're going to skip over the R square, and you're going to use the R. So let's write this. It's going to be y equals, now it says 0.890. So let's just write 0.89x. What is that? All right, so here we go. So y equals 0.89x. Again, the calculator is telling me what to write. Now let's go back. And now it says 8.045. That 5 tells me to round that 4 up to a 5. So let's write that. Again, I keep clicking that. So plus 8.05. And you just found the best fit line. But it also said find the correlation coefficient, which is the R. The R. National Pirate Day. R. So you go to the R and it says 0.945. So that 5 tells you to round up. So you get 0.95. But it didn't just say find the correlation coefficient. It says what does it mean? Interpret it. So first of all, is that number positive or negative? It's positive. So we're going to write a positive correlation. But now, if it's 0.95, is that weak, moderate, or strong? And since that's very close to 1, we're going to say it has a strong positive correlation. And that's the lesson, and we only got one more in the algebra curriculum. Crazy. Miss you guys. Bye.